Good afternoon, ladies and gentlemen. On behalf of EUROSAC and CEPI Eurokraft, I have the great pleasure to welcome you to the first session of this year's two-part webinar series that we are hosting under the topic Unwrapping Sustainability Across the Value Chain with Paper Sacks. It's great to have you all join us. My name is Ingo Tyson, and I'm looking forward to guiding you through the upcoming program. So today, we will talk about closing the loop, advancing recyclability in paper sacks. This loop refers, of course, to the concept of a circular economy. By balancing economic growth with environmental stewardship, it offers a holistic approach to addressing some of the global challenges of our time, such as sustainable waste management, resource conservation, and environmental protection. Recycling is a key component in closing the loop by reducing waste and ensuring that materials are used and reused efficiently. And while recycling rates for fiber-based packaging are already quite high in Europe, they need to be increased further to meet the growing environmental demands of consumers and businesses, as well as legal and regulatory requirements such as the Packaging and Packaging Waste Directive. As one of the most widely used types of packaging for powdery and granulated goods, paper sacks play an important role. So today we will talk about how to promote a circular economy by further advancing recyclability in paper sacks. So let's take a quick look at the program. We have an hour time and we will see three short presentations. Michael Sturgis will start with this presentation about the test results on paper sack recycling in regular recycling streams. After that comes Elena Sofiato. She will be presenting guidelines to help optimize the recyclability of paper sacks by design. And last but not least, Aina Solé Garrigos will share some practical insights into opportunities and challenges that recycling paper sacks and using recycled fibers in new products can entail for a producer. Please note that the full webinar will be recorded and made available for streaming afterwards on eurosac.org. Also, each presentation will be followed by a question and answer session in which you can all participate. To do so, please submit your questions anytime during the speeches by using the Q&A button, which you find on the bottom of the Zoom application. There you can also see the questions of other participants, and by liking a question, you can upvote it. The questions will be answered at the end of each presentation, and please note that the chat function remains deactivated the entire time. So to increase interactivity, I strongly encourage you to actively use the Q&A function. If there is not enough time to answer all questions, you can always send an email to info@eurosac.org, and we will try to answer it in the follow-up. So what else is there to know? We will also have a survey before each presentation that will automatically pop up on your screen. And you can participate by simply clicking on your preferred answer. And I suggest we do our first survey right now to check if it works for everyone. So here it comes. The question is, are paper sacks recyclable in regular recycling streams? Yes, no, not sure. So please make your choice. I will wait a couple of seconds to see what you decide. And take a look at the results. Well, the majority, 72%, say that they are recyclable in regular recycling streams. That's great. First of all, thanks for your vote. And I'm sure that our first speaker will provide us with clarity on this issue. And here is already, let's welcome Michael Sturgis, research consultant at RISE Research Institutes of Sweden. And Michael has more than 25 years of experience working with environment and sustainability issues applicable to fiber-based and bio-based materials and products. He has a strong focus on data-driven analysis for informed decision-making and is skilled in the application of techniques such as life cycle assessment, carbon footprint, and GHG assessments. And today he will talk to us about the recent test results on current paper sack recycling in regular recycling streams. Welcome, Michael. And allow me one question before you start your presentation. So do you have any spontaneous thoughts on the results of the survey?
Yeah, so the results were very interesting. They really tie in well with what we've learned and what we're going to present in the next slides, which actually hopefully really demonstrate that paper sacks are recyclable in standard recycling streams, which has been something that has been a point of contention for some time with conflicting views and answers. So we have hopefully some sound and independent evidence to back that up.
Okay, thank you very much for your opinion. Well, then we're looking forward to your presentation. The floor is yours, Michael.
So, through EUROSAC and CEPI Eurokraft, we've actually been looking very much in detail at this question as to whether paper sacks are recyclable in standard mill recycling processes. The first thing that we did was to apply a desk-based or a lab-based test of paper sacks to demonstrate recyclability, to ascertain, what is the level of recyclability of different paper sack constructions. And these tests were carried out by CQC in Lucca. This is a well-respected paper testing laboratory, very experienced and skilled in recyclability testing. And we did a standard test method for recyclability on various paper sack constructions. And those paper sack constructions represented, we believe, more than 80% of the paper sacks on the market in Europe. And the method we applied was the CEPI recyclability laboratory test method version 2. And we combined that with the recyclability evaluation protocol, which is developed by CEPI and Forever Green, to grade the recyclability of the different paper sack constructions. The lab method helps us determine the level of recyclability by assessing different process and quality parameters. So by process parameters, we're looking at how much reject is generated from the paper sacks in the recycling stream, coarse reject and fine reject, and how much dissolved and colloidal substances are produced, and what the implications are in regards to sticky particles. And then for quality parameters, we're looking at how well the fibers can form a sheet, what that sheet adhesiveness is, and what visual impurities are present. So really looking at the quality of the end product that can be produced when paper sacks are recycled. And this method simulates the recycling in a standard paper and board recycling mill. That's the aim of this particular test. Once we have those different parameters evaluated, we can calculate a total recyclability score. And that's the sum of the yield score, the visual impurity score, and the sheet adhesion score. And we get a recyclability score of between 0 and 100. Sorry, we need a recyclability score of between 0 and 100 to demonstrate that a package is recyclable and considered suitable for standard mill recycling. And depending on the yield score, we get a ranking of that recyclability. So a score of 90 to 100 is a package that is best in class, i.e. the most recyclable we can anticipate. Score of 70 to 89 means that it has minor repulpability issues. And a score of 50 to 69 means that it has some recyclability issues. This doesn't mean that it's not recyclable. It just means that there are some issues that may occur in the recycling process, but they should be manageable. Okay. A score of less than 0 means that the package isn't recyclable in a standard mill, and you may need to look for a special recycling mill to deal with it. Very briefly, These are the test samples that we investigated. 5 different samples. I won't go through the detail, but the sample 1 was representative of a printed valve sack for flour. Sample 2 was a printed valve sack for cement or building materials. Sample 3 was a printed open mouth bag for animal feed. Sample 4 was a printed open mouth bag, but with a plastic outer tube for protection, and that was for powdered milk. And sample 5 was a printed open mouth bag for pet food. They all have different potential challenges when we think about recyclability. All of the tests were made on unused paper sacks. Apart from sample 2, we also tested a previously used sack that had been fully emptied, shaken and emptied, to see what implications there were for recyclability. I won't cover all of the results, but just some highlights. Sample 1, you can see, scored 96. So it was considered best in class in terms of coarse reject and fine reject. It's suitable for standard mill recycling. Sample 2, the unused paper sack, the unused cement bag. Again, it scored 80, so it has minor repulpability issues. It passed on the visual impurities and sheet adhesion, and it's suitable for standard mill recycling. Even the used and shaken empty cement sack still scored as a suitable for standard mill recycling result with minor repulpability issues. The one sack that failed the test was sample 4, the printed open mouth bag with the outer plastic tube, quite a high gauge outer plastic tube for protection for hygiene purposes. And this one didn't pass the test. It wasn't suitable for standard mill recycling. However, this product was tested with the outer bag, okay, with the outer liner. If the outer liner was removed, it would have probably, well, it would have passed the test. And this sack is designed to be separated. The elements are designed to be separated after use. So this result really represents the worst case scenario if the sack and the liner are placed into the recycling together. So a summary of the recyclability testing. Well, all of the sack configurations passed the test as suitable for mill recycling, apart from sample 4 with the heavy gauge outer liner, but without the outer liner, or potentially with a lower gauge liner, it would have passed. So, having established that the paper sacks pass the recyclability test and can be classified as recyclable, our next question was, well, why would a standard paper mill want to take in paper sacks? Is there any benefit for them? So we did a lab-based investigation, and this investigation was carried out by RISE and Test Tech UK. And what we did was we repulped sackcraft paper combined with 100 GSM recycled test liner at various mixes. You can see here, trial number 1 was 100% liner, recycled liner. This was our control, effectively. This is what mills might accept today. Trial number 2 was 95% liner, but 5% sackcraft paper. Trial number 3, 80% liner, 20% sackcraft liner, etc. 7 different mixes. And what we did was we repulped that mixture together and then prepared hand sheets from the pulp and tested the properties of those sheets. And the properties we tested for were average fibre length and then hand sheet paper properties, tear index, burst index, tensile strength. Then we tested the pulp drainage rate and the ash content. Fiber length, tear index, burst index, and tensile index are all important properties that demonstrate the strength of the paper. Pulp drainage rate and ash content, well, these demonstrate how easy it is for the paper to be formed and dried on the paper machine. To summarize the results, you can see there is a clear relationship between the increase in the percentage of sack kraft fiber in the fiber stock and each of these properties. So just including 5% sack kraft fiber, we saw a 15.5% increase in tear index, a 2.2% increase in tensile index, a 2% increase in burst index, and a 7.1% increase in pulp drainage. And we see that increasing as we include greater proportion of sack kraft fiber. So at 20%, we saw really significant increases. It's pretty much a linear relationship between the proportion and each parameter. So what we're demonstrating here is that including sack kraft fibers improves the quality of the paper that is produced. It's stronger. And also it potentially makes the production of the paper easier. By reducing the pulp drainage and the ash content, we're making it easier to form and dry the paper on the machine, and therefore potentially reducing energy consumption, potentially reducing carbon emissions. This, of course, is all lab-based at the moment. The proof will be, can we transfer these results from the lab to the real-life situation? So in the future, we want to look at trialing this with a real-life manufacturing scenario. So to conclude, an important knowledge gap has been filled. There's been a lot of debate in the industry and amongst the recycling industry in particular as to whether sack kraft paper and paper sacks are recyclable in a mill and whether they should be included in the fiber furnish. So the results from the testing and investigations are a big step forward. They're very positive for making the case for paper sacks as not only recyclable in standard recycling mills, but also a potentially desirable constituent of the fiber furnish. And this work has been written up and published in the latest edition of the Paper Industry Technical Association magazine journal. So it's available. You can take a look at that journal, take a look at the article, and read in depth the science behind this analysis. Thank you. Any questions?
Well, thank you, Michael, for this insightful presentation. And a little reminder to the audience, please send in your questions for Michael. So this is your chance to ask everything you always wanted to know about recycling paper sacks in regular recycling streams. Well, while we are waiting for questions from the audience, I got a question, Michael. So what are actually the components in a paper sack that are hardest to recycle?
Yeah, so that's a really good question. What we saw was that, in particular, the polymer layers used for adding barrier properties to the paper sacks, these will increase the amount of coarse and fine rejects in the sample. So these will not be recycled; they'll be rejected at the mill, and they become a waste stream. So that is clearly something that we can work on. Can we minimize the amount of polymer? Can we reduce the polymer with other more natural materials? our study focused very much on the paper sack, the main body of the paper sack, but there are other components of the paper sack that also have potential implications, such as the adhesives used, anything like additional things such as carry handles, tie strings, etc. But those are going to be very much addressed, I think, in Eleanor's presentation on design for recyclability guidelines. So I think she can pick up some of those points in the subsequent presentation.
I'm sure she will. Well, we got 2 more questions that came in from the audience. So the first is, what effect will it have on recyclability if the sacks are not emptied fully?
Yeah, that's a really good question. So what we know is that residues in used paper sacks can be a problem in the recycling stream. Again, they will contribute to the coarse and fine rejects in the test. We saw that a little bit with the used paper sack that we tested. We shook that empty so that it was representative of something that had been properly emptied. But if residues are too high, they will be a problem for mills. So one thing that we need to think about is, how do we encourage the end user to properly empty their sacks before placing them in the recycling?
Okay, so topics like consumer education comes into mind there.
Yeah.
All right, there are more questions coming in. Well, the questions are getting longer and longer. So the next question is, how much does this match what paper mills will actually recycle? We have had feedback in the past as the plastic layer isn't liked as it needs to be disposed of at the end of the process.
Yeah, this is a good question as well. So I think there are 2 things at play here. There's a natural reluctance by standard paper recycling mills to take anything that isn't 100% fiber, that isn't going to give them 100% yield. Obviously, if they can just recycle old corrugated cases, that's what they want. It's easy for them to repulp. It doesn't have a polymer liner or layer. So there is a natural reluctance, but that reluctance is often based on belief that the sack will be impossible to recycle, rather than slight impediment to recycling, as we demonstrated in the testing. So I think this work can help make the case to the recovered paper mills that paper sacks are recyclable. And the most important part is the work that demonstrates the additional benefits that they give. So there is a trade-off between, perhaps slightly longer pulping time, but better quality end product, perhaps slightly larger proportion of reject versus better end product. So the next step for us is really to work with the mills and advocate to them and try to prove in reality that this is a desirable part of their fiber furnish.
Okay, thank you. You got one last question. Actually, we have to move forward to the next topic, but maybe if you can answer this quite quickly, Michael, maybe we can still pick it up. Otherwise, maybe you can answer it afterwards in the Q&A in written form. So the question is question about the test results for used cement bags versus the unused cement bag. Why does the used bag score better? I think 83 versus 80. Yep. I had expected a higher score for the unused bag.
Yeah, I think this just reflects the degree of uncertainty or natural variability in the test results. Every test will have some variability around it. If we'd have done more samples, that's exactly what I would have expected as well. But just taking one sample of each just means that we're subject to the natural variability in the test method and the results.
Okay, thank you. Thank you all for your questions, and thanks, Michael, for your contribution. We will see you back on screen before we close. And so to the audience, if there are any other questions popping up or coming to your head afterwards, you can still either enter them in the Q&A so that Michael can maybe answer them in the webinar, or you can send us an email on info@eurosac.org. So let's continue with our second survey question. The question is, there it is. What do you think is a weak aspect in paper sacks recycling? In this case, there are multiple answers possible, so you can choose every option that seems relevant to you. Okay, well, yeah, this looks quite balanced, I would say. We have 63% for not all components of paper sacks are recyclable, and the other two are following very closely. So thank you all for voting, and I am certain that our next speaker will enlighten us on the issue. A warm welcome to Elena Soffiato. She is a member of the expert group that developed the paper sacks design of recyclability guidelines. And as a sustainability manager at Mondi, Elena has a focus on industrial paper sacks. Prior to this role, she held different senior roles in sales and operations at one of the largest Mondi plants dedicated to paper-based solutions for the B2C and B2B market. And today she will present the paper sacks design for recyclability guidelines. So Elena, welcome. Before you start, so what do you think about the results of our survey?
Thanks, Ingo. The audience is right. I mean, all three answers are correct, because all these three elements need to work together to make our bags recyclable at scale. But we can talk together now with going through the guideline that we prepare. So we will try, at least partially, to give some answer to the audience about how should be made the bags to be recyclable. First of all, we need to say that CEPI Eurokraft and EUROSAC developed this guideline because we are really committed to a transition to bio-based, so renewable source, low carbon. It means that when we are thinking to a new packaging, we are also looking at the carbon footprint that we need anyway to reduce as much as possible, and circular economy. As Michael say, the raw material used in our paper sacks is a good material of added value. So we needed to find a way to keep in circulation. The second thing is that we need to respond to the market needs for recyclable packaging. And the third one, we must be ready and prepare for the upcoming regulation. As you mentioned, the packaging waste regulation that is requiring not only that the packaging is designed for recycling, but that is recycled, that is a recycled packaging. And these guidelines were developed looking at existing guidelines like Forever Green, CEPI, FEFCO, and others, steered by a working group made of paper sacks producers in order to have the knowledge of performance of the bags, of the material, consultant, expert of the industry, for example, people from the converting machine supplier, because they are also part of the process. And then a review by stakeholders. First of all, recyclers, because they are the ones that are taking the material and adding in their recycling process. So they are really the ones that know what can fit or what doesn't fit in their process. Then clear Forever Green and CEPI as well. And then, as Michael presented, we made a recycle test on paper sacks with the composition that are representing the main markets. Before starting looking to some highlights of the guidelines, we need anyway to have a definition of recycling. And here we can say that recycling for paper-based bags is the individual suitability of a paper-based packaging for its factual reprocessing in the post-use phase into new paper or board, where factual means that separate collection, where relevant and followed by sorting into EN 643 grades, that is the grades for the recycler, and final recycling takes place on industrial scale. This definition is very important because it tells us which are the key elements that must be fulfilled in order to have a packaging that is recyclable. First, as we say at the beginning, is what was in the survey, exactly the same. We need to have an existing collection and sorting system in place that covers significant and relevant geographical area. It means that I need to collect enough volume and cover enough area. There is an existing recycling system in place, so it means that there is the technology and the industry for recycling the packaging. And what we are talking today, the individual packaging is designed to fit with this system and processes. So that's the reason why the guideline can be really useful, because help really to respond to the needs of the other players in the supply chain for recycling. On the design, on the guidelines, we look at different parameters. First, the fibers used, the additives agents, the non-fiber components, from the free film to the coatings to the lamination, ink and varnishes, adhesive and additional components. There will be a clear description for each of them, but then they will be marked also in different color. When green, it means that they fit perfectly with existing sorting and recycling process. When yellow, they are, let's say, still they can still be reprocessing and recycled, but they can cause some issue during the process, or maybe the outcome, the output of the recycling process in terms of quality and quantity can have some effect. Clear that some other tests can be done on this type of elements. In red, these are the elements that, based on the knowledge, based on the experience, they can cause a major issue during the recycling process. And in gray, what needed still to be tested, where we have not enough knowledge, where maybe the quantity used now is not enough to have a clear view on how is the effect, what is the effect on the recycling process. Now we look quickly to some elements of the bags, and we will highlight the one that maybe we need to keep an eye on. First, for the fibers, the wet strength paper. This, in this case, is conditionally compatible with the recycling process, because in standard recycling mills, because clearly, depending on the quantity of the wet strength agents, on the chemical that we use, but the knowledge, experience that they can cause some issue during the recycling process. So the suggestion is to use as minimum as possible, to reduce the minimum, or to avoid this kind of material into the bags. Further tests clear can be made. The other element is the free film. That is one component of our paper sacks. In this way, in this case, when it is polyethylene, the PE, there is no issue during the recycling process. The only suggestion that we give in the guideline is to keep the quantity of this material as less as possible, because and the suggestion is to keep between 1–10% of the weight of the bags, when it is from 10 to 20, to make a recycling test to check really the quality of the outcome of the recycling process. When in case of other fossil-based or bio-based film, at the moment we don't have so much knowledge, so a test is recommended. In case of barrier coating, that is very similar to anyway lamination, we need to distinguish different cases. When the coating is just one side, and it is as inner ply on the bags, it's not an issue for the second process. Always take into account that we need to use as much as possible the less quantity into the bags, because we are talking about paper recycling process, so we need, as also Michael said, to reduce as much as possible these different elements. So always the ratio is 1:10 fine, more than 10, better to have from 10 to 20, have to have a test. More than 20, better to avoid. But if it is one side, it fit. If it is one side and external, there could be some issue on the sorting process, because here we use the technology near, and the system could recognize these bags as a plastic and not as paper. So it's something that we need really to look at. And then when it is a two-side coating or lamination, in this case, it doesn't fit with the standard recycling mills because the process is in some way compromised, and we need to look at special recycling mills. Additives, the one of the aspects to take into account is, for example, the hot melt and the melting point, that when it's too low, it can create a micro sticky formation on the recycled paper. So if you use hot melt, look at the melting point, that should be more than 68. Great. Additional components. That is also something that we need to look at. For example, carry handle, plastic window, easy opening. Also in this case, they are conditionally compatible with the recycling process, because they will be part of the rejected in the process of the recycling. And then again, if it is plastic, could interfere with the sorting process. Further advice. As it was shown on the test made for the different type of bags, when we need to use plastic because it's needed, to give the barrier to fit with the supply chain. In this case, look if possible to design the bags for material separation, so that the two material will take two different streams, plastic and paper. Then to design to reduce the unintended product residues, in this case, easy to pour, that the bags will be empty. Also because beside the effect that it could have on the process, like Michael say, then there could be, for example, some case in case of food of infestation for insect during the process. And then liability communication. If our packaging can be recycled, we need to tell, we need to inform, and also to give instruction to the end user. To finish, the technology and the policy related to collection, sorting, recycling is changing. It's changing faster because a new technology are coming in terms of sorting, reprocessing, and recycling. There are new regulations coming, new requirements, in particular in Europe with the Circular Economy Action Plan, that where, all packaging by 2030 should be recyclable or reused. And then also because other guidelines could be developed. So, and then there could be some further insight for our guidelines for paper sacks. So this guideline will be regularly updated as necessary. I really invite you to look at these guidelines on the website of EUROSAC or CEPI Eurokraft. You can download them and really go through them. I think that it will be really useful. Thanks.
Thank you, Elena, for this comprehensive overview of the guidelines. I'm checking, there are no questions yet. So if you have any question for Elena, please send it by using the Q&A function. But I have a question in the meantime, Elena. So who in general is responsible for ensuring the design for recyclability?
That's a good, that's really a good question, because as you have seen, different stakeholders are in the process. So clear, as first of all, as a producer, we need to have a clear how a packaging should be, how it could fit with the other process, the sorting, the recycling, and we should the one that promote to our customer. But we need as well the cooperation of our customer, and on the side to be very close to the recycler, to the collection and sorting players, in order to further improve. I think that is really a process, and we will not be the only one doing that. So it's really a cooperation among the different players.
Okay. Perfect. Thank you very much.
You're welcome.
No other questions for the moment. Well, reminder for the audience, if there are any other questions coming to your mind, please, if it's still during the webinar, you can post it in the Q&A section and Elena can maybe answer it by written. If it's after the webinar, you can still send us an email to info@eurosac.org. So, Elena, thank you for the moment, and thanks, of course, also to the audience for your interest. And Elena, we will see you back on screen before we close as well. So it's time now for our third survey question. And here it comes already. So what is the most important aspect of paper sack recycling for you? Good fiber source, increased recycling rates, or reduced environmental impact? You can only choose one, the most important aspect for you. Some 60% have participated yet. Well, I think we can close the survey. Well, it's quite obvious. It's quite clear. It's the reduced environmental impact by far. And also, but very much later on the second place, good fiber source and increasing recycling rates. So thank you all for voting, and I'm looking forward to hearing our final speaker's perspective on the question. So please welcome Aina Soler-Garrigos. She is R&D project coordinator at Allier. And for this particular role, Aina has received specialized training, including in chemistry and additives. She also specialized in quality control testing in the paper industry. She has actively participated in various research projects centered on cellulose fiber properties and morphological modifications to create a wide range of products with a specific focus on the development of sacks and bags. And today she will share with us valuable insights into paper sack recycling in mills. So welcome, Aina. Before you get started, what do you think about the results of our little survey? Do they meet your expectations?
Thank you, Ingo, for the introduction. So by recycling paper, we minimize the environmental impact because we reduce the volume waste ending in landfills or incineration. So we also reduce the greenhouse gases. Also, we preserve forest and the natural resources, but I think that all the three options are also correct and important in the context of paper recycling, because you need good fibers to produce high quality of sacks, and also reducing or increasing the recycling rates, you reduce also the waste. So.
Perfect. So there's no wrong or right. It's all important. It's just a question of individual perspective. Okay, then, Aina, we are looking forward to your presentation. The floor is yours.
Okay, so this is the content that I am going to present you. Our journey as a waste revalorizers, our circular production, our decarbonization plan, and finally some conclusions. So today I am delighted to present Allier, a pioneer in the field of waste recovery, where waste becomes a valuable resource. We have been producing recycled paper since 1948, making recycling an integral part of our identity. Already in 1977, we started producing the semi-extensible paper. Our circular paper manufacturing model involves producing 100% recycled sacks from recovered sacks. The process begins with the purchase of sacks, with the 60% originating from the national market and the remainder coming from the European Union, primarily Germany and France. This raw material is crushed, purified in the stock preparation, and once the paper pulp is suitable, it is fed into the paper machine to form the paper reels. After the sack has been used, we rebuy it to reintroduce it into the process. if we start from the beginning, we obtain 3 types of sacks. Used sacks, there's the photo on the left, can come from various sectors such as agriculture, food industry, pet food, and construction. They are all post-consumer sacks that can contain dust from the material that they have held. The new sacks, the 2 photos on the side, whether with or without plastics, they offer a good significant advantage. These new sacks, they are obtained from production surplus or manufacturing defects. Although they represent the highest quality of sacks, their volume is minimal compared to used sacks. New sacks containing plastic do not offer for us any problems, although their efficiency is slightly lower. This polymer material, the plastic, will form part of the reject stream in our mill, and we valorize through a treatment line. In addition of these 3 qualities, we incorporate beverage cartons highlighted in pink, which are raw materials that they are difficult to valorize and have a high content of contaminants. If we don't consume it, they can also end up in landfills. In this graph, you can see the sacks consumption, and the vast majority are used sacks, the columns in blue, coming from the construction sector. It should be noted that the sacks are also used to produce other products such as plasterboard liner. However, these sacks often suffer poor management and sorting practices, and frequently we get them mixed with cardboard and other waste materials. Therefore, we assist and advise the Scrap Association to advocate for high quality recycling of these materials. So by doing so, we aim to drive circularity and recycling initiatives that align with the European Union's set objectives. If we look at a microscopic level at the fibers that make up the sacks, sacks are composed of high quality of fibers. They have entire length, good width, and few fines. So recycled fibers are suitable for manufacturing new sacks. To check if we can recycle the sacks, we conduct an analysis that includes repulpability, the ash content, the inorganic content, the yield, that would be the plastic reject, the drainage degree, and biometric parameters of the fibers using an automatic analyzer called Morphing Neo. To exemplify some results, the photograph highlighted in green is a sack that contains wet strength, but we can consume it in our paper mill. However, those raw materials that contain product residues in high volume, cement, plaster dust, granules of PVC, PVA, or dyes that may adversely affect the mechanical properties of the final paper, they are rejected, which would be the photograph highlighted in pink. Continuing with the manufacturing process, once we have selected the bales, the crushed and clean pulp goes through the forming section, when in 2020 we made some upgrades for the manufacture of semi-extensible sacks. We install an extensible unit called Clupack. Finally, we generate a paper with 100% recycled fibers. These sacks offers good mechanical properties. They are ideal for producing construction materials, but also for other sectors, such as food industry. We are currently selling the product in European Union, Africa, and Latin America. And with the FSC and PEFC certifications, we ensure that our paper is 100% recycled, and we comply with the chain of custody. We have a SEGA certificate that is compliant with all the regulations for manufacturing materials for packaging products that they are in contact with food. And we rely on ISO certifications to improve our process, services, and products that ensure the client increase the degree of confidence in them. And finally, this is our decarbonization strategy that will allow to reduce 59% the reduction compared by 2025 compared to 2020. The decarbonization plan will serve as a guide to direct investments in the coming years. So nowadays we have biogas boilers to burn all the biogas produced in the water treatment plant, and we have installed photovoltaic panels on the roof for self-consumption. In 2024, we will install a biomass plant to replace the cogeneration plant. We will also install a sludge digestion plant and more photovoltaic panels on the roof. In 2025, we will install photovoltaic panels on agricultural land. To summarize the key ideas, there must be sorting systems on site to increase the recycling of paper sacks. An exhaustive quality assessment of raw materials is carried out to see their potential for recycling. Fibers from paper sacks recycling are suitable for manufacturing new sacks, and recycling of paper sacks at the end of life should be encouraged and pursued. If you want more information about our company and products, I encourage you to scan the QR code. Thank you very much.
Thank you, Aina, for this insightful presentation about the practicality of recycling in mills. So while we are waiting for questions from the audience coming in, let me ask you a question. So what are the most common challenges actually in production of recycled paper sacks, and how are they addressed? The recycled paper often contains high level of contaminants such as I have said, cement, plaster, flour, also some granules of PVC, PVA. So these kind of materials with high volume of residues, they are rejected because they can cause problems in the pulping process, during the purification of the fibers, and also at the end on the mechanical properties of the sacks. So to address this issue, it's highly important to identify and have a good quality assessment on the raw material, and also to encourage to have a good sorting and a good management on site when the sack is used. Okay, thank you. There's one more question that just popped in. How is the quality of recycled paper sacks ensured in the production process?
Yeah, the quality is ensured during all the process. We begin with the high quality assessment in the raw material, but also during all the process. We have a good knowledge and a good know-how of our stock preparation, because all the equipment is adapted for recycled fibers. So we ensure the quality during all the manufacturing process, to begin at that and also at the end.
Okay, thank you. Any other questions for Aina? Well, apparently not for the moment. So again, the reminder, if you have any questions coming to your mind later, you are very welcome to send us an email at info@eurosac.org. Oh, there's another question that just came in. Where are used bags coming from?
Mainly they come from the construction sector.
Okay. So with building materials? Are they often
sure.
And are they fully emptied, or are they?
Sometimes they are full of contaminants that they have held, but those they are rejected. But sometimes with just dust, we can consume it here.
Okay, thank you.
If they
Now,
just contain...
Audi stipulated, she asked from Europe, so apparently it was the question was aimed at the geographic area. So where do they come from, the used bags?
I can't provide the exact number of the country that they come from.
No, not the country, but are they mainly from Europe?
Yeah, for
Yes.
sure, mainly for Europe.
Perfect, thank you. Okay, so no more questions for the moment. Thank you very much, Aina. And again, we will be happy to answer more questions on info@eurosac.org. Well, ladies and gentlemen, that was it for today. Thank you very much for your participation, and we hope this webinar has been valuable to you. The recording will soon be available on eurosac.org. Any additional questions and comments, I've said that already quite some times now, can be sent to info@eurosac.org. And of course, a big thank you to our speakers, Michael Sturgis, Elena Sofiato, and Aina Soler-Garrigos. We really appreciate you taking the time to share your knowledge with us here today. So thanks to all of you, and enjoy the rest of the day, or of the evening, better said. And I would like to use the opportunity also to give a quick info to the audience. Please also note that our second session will take place next Thursday, so next week on November 16, from 4 p.m. to 5 p.m. The topic is Beyond Packaging, exploring the LCA of paper sacks, once again with great speakers and topics. So we have Judith Rupert-Soltowski. She will talk about the significance of the Corporate Sustainability Reporting Directive and Scope 3 emissions. We will have Alexander Rossner from Zukunftswerk. He will give insights into the impact of life cycle assessment on corporate value and economic performance. And we will see again Michael Sturgis, who will present the outcome of the recent LCA study for sackcraft paper and paper sacks. If you haven't registered yet, you can still do so. You will find the registration link in the chat. As it is not an active link, please proceed by copying it and pasting it into your browser. So I'm looking forward to seeing you again next week. Thank you for participating, and goodbye.